Welcome to Faith and Science. I'm Dr. John Ashton. Recently I was reading an article about the fascinating Bombardier beetle. So this is a little insect. They grow, somewhere just a bit bigger than a centimetre, maybe up to 2.5 centimetres, some of the specimens that are found in places like Africa. But this little insect emits a very hot spray to ward off any predator. This little spray is squirted out the rear of the insect, and it's a mixture of hot water, very hot water, and steam, and it actually contains some caustic chemicals as well. And it sort of is used to ward off any attacker. And I was quite surprised that we have these insects in Australia. I had read about them before, and I suppose I hadn't paid a lot of attention to them, but they occur just pretty well in all the continents, America, Asia, Africa. And as I said, I was very surprised to find that they were here in Australia as well, because I've never seen one. They are certainly fascinating little creatures. One of the experiments that I was reading about was that when if they put these little Bombardier beetles down in the presence of toads, the toads race over and gobble them up. But then the little beetles fire off this caustic material, and most of the toads vomit them up quite quickly. Some of them actually, they're in one of the experiments, I think if I understand correctly, these little beetles, this caustic material was actually able to blast its way out of the toad's stomach. But most of the time the toads then just vomit them back up, and they survived. And the little beetles that got vomited up survived quite well, and the other ones that crawled out. The chemistry behind the Bombardier beetle is quite fascinating. Now, its technical name is Bombardier brachini, and they live in mainly the warm parts of the world, but also apparently they're even found in Europe, and even in southern England, some small colonies of these beetles have been found. They're quite a pretty beetle, and they hide under rocks. But one of the things that's fascinating for me is the chemistry of how they can produce this very hot caustic substance that they emit. And it's actually a mixture of chemically heated steam and these noxious chemicals that come out of its back end. And it has this little turret. And it literally is like a gun turret, in that they can move this turret around to actually fire over their back, or underneath, or to the side. So they can swing this little turret around. The other, because their predators are things like birds and spiders, frogs, toads, and even ants can attack them, of course. And the chemicals, it's quite fascinating, don't come out as a continuous stream. And in fact, it really wasn't till 1999 that a research paper was published in the Proceedings of the National Academy of Sciences in the United States on the 17th of August 1999 by Professor Tom Eisner. And he showed that, in actual fact, the beetle produces a series of explosions, one after another, in rapid successions. He did quite a clever experiment where he filmed a African Bombardier beetle and then played it back in very slow motion. And as he studied the film, he found that the little beetle actually was producing about 500 explosions per second in rapid succession. So it's like very, very fast machine gun fire in repeated bursts. And so these then bursts were emitted, very brief bursts, just for 2 to 3 seconds, and then it stopped, then another 2 to 3 seconds. And the beetle could do this 4 to 5 times before depleting the chemical system. But then, of course, the chemical system actually recovered a few minutes later again. So there's quite a lot of potential there. Now, one of the things that they've found is that the two chemicals that are combined, one is hydroquinone and the other one is hydrogen peroxide. And there are also two catalysts that are required, catalase and peroxidase, that are required to make the chemical reaction go. There are also special valves that control these blasts. So the fact that those little blasts, up to 500 per second, were controlled by a very unique valve system where the high pressure caused the inlet valve to close and an outlet valve to open and resulted in a violent vapour explosion or flash evaporation where a substantial amount of the liquid water that was in the little body of the little beetle expands into steam. Now, steam, of course, when you convert water into steam at standard pressure, you get an increase in volume of about 1,600 times, 1,600 times. So if you contain this, you generate a lot of pressure converting water into steam. Hence the principle of the steam engine. And we know steam locomotives can be very powerful and generate maximum torque right from start. And so you have this extreme pressure is there. And so as this expansion occurs very rapidly, it carries this remaining water with its caustic chemicals in it in this spray. And the force is such that it can reach about 20 centimetres. So when you think this little beetle is about just over a centimetre long, up to maybe 2 centimetres, although some of the bigger ones 2.5 centimetres, but in that, and it can fire about 20 centimetres. So it has a range roughly 10 to 15 times its length, or even so. It's quite powerful. It reaches about 20 centimetres. So and that's about, when you think the little combustion chamber itself is only about 1 millimetre long. So that's the length of the little chamber. So it fires about 200 times the length of its chamber. Actually, David Attenborough produced a series on the Bombardier. Well, it included the Bombardier Beetle. It was in the BBC Life series, number 6 on insects. And of course, it's interesting that David Attenborough attributes all this amazing chemistry, amazing design, just to random evolution. And I really don't think that David Attenborough, he produces some amazing films, really understands that all these structures have to be produced in a code made up of chemicals that we represent by the letters A, C, T and G. And he claims that by random sorting, by mutations of these A, C, T and G that we're going to produce these amazing structures that work together. Well, I think really as we think about it seriously, it is absolutely very powerful evidence of irreducible complexity. In other words, unless this system is all together and in just the right amounts, the insect's going to blow up or it's not going to work. It's going to, scald itself, destroy itself. There's so many things there that it's not going to work, and it's going to be very harmful in the development processes unless everything is in balance. And matter of fact, dissection of the rear end of the beetle have shown an amazing amount of detail, and the chemical defence is actually quite sophisticated. You see, before the two chemicals can react, they actually have to travel down a very thin tube together where the catalysts are either secreted or possibly are there in crystalline form in the tube. So what this is saying is that at the present time, as we're studying this Bombardier beetle, we still don't fully understand how all the structure is. So here we have, scientists trying to understand how this little beetle works, but we're still not exactly sure how the catalysts are exposed to the particular chemicals. So the catalysts, catalase and peroxidase, act on the hydrogen peroxide and hydroquinone, and the hydrogen peroxide then converts to water and steam as a result of reaction. So a catalyst, by the way, is a particular chemical that speeds up another chemical reaction. And the catalyst itself actually isn't used up. It's just there, but it just helps the other action speed up, often by reducing what we call activation energy. So if you think about this, if you think of if you want to set fire to, let's say, to petrol, if you have petrol in air, it just doesn't burn. The petrol just sits there, it'll evaporate. But if you apply heat to the petrol, then what happens is sufficient heat to the petrol, then you overcome what we call the activation energy, and then suddenly those chemical bonds will become reactive to the presence of oxygen and begin to burn. And that's, of course, the principle of the internal combustion engine. And, of course, we generally heat that. You could heat the petrol with a match. You'd have to be very careful because it'll flare up. But the heat from the burning match or burning piece of paper or burning anything, that flame provides the energy to overcome the activation energy. Or in an internal combustion, like car engine with a spark plug, you produce an electrical discharge, produces a very high little plasma of that is charged on ionic particles, very high temperature, which we call a little spark. And that high temperature, again, provides the initial activation energy to start the reaction going. So it's the same with these catalysts. So these catalysts provide in some way the ability for those reactions to take place. Now, the hydrogen peroxide, as I said, converts to water, but because there's heat liberated at the same time, it converts to steam. And it also splits off oxygen. Now, that is it splits off an oxygen atom. So that oxygen atom is very reactive now. It's not an oxygen molecule, it's an oxygen atom. So it's a highly reactive species that is going to react with something nearby very quickly. And then every model of one atom of oxygen comes from every molecule of peroxide. And then this combines with hydrogen molecules which are released from the hydrogen quinone. And that produces, that's essentially burning hydrogen and burning hydrogen. So the hydrogen combines with the oxygen, and of course we know when that reaction occurs, it produces a lot of heat as well. And that, of course, produces hot water. So when you burn hydrogen and oxygen together, you get water, and that produces very hot water. And that hot water, of course, expands, produces steam, and produces this vapour explosion that is mixed with some caustic chemicals. And these valves, of course, operate and regulate the pressure and the burst coming out. It's interesting, the exit tube is enclosed by a membrane that blocks the bottom part of the tube. And once the chamber is full and the chemicals react, the extremities of the chamber itself, which are pinch the tube shut, and as the chemicals in the chamber progresses, the heat is generated and the pressure in the chamber increases till the membrane is forced to open near the exit tube and fires the droplets of and steam vapour out. Now again, the material of this chamber has to be of a very heat-resistant membrane, because we know for water to be steam under pressure, it has to be well above 100 degrees centigrade. And so again, those sort of temperatures break down generally a lot of proteins and these sort of things. And we know when you cook an egg, you take it up in temperature, then you change the proteins, it goes from liquid to solid and so forth. And so again, we find that that particular chamber is lined with a particular membrane that prevents the beetle from cooking itself. And so this is the other aspect of design that, again, is all pointing to the fact that this system just couldn't evolve, because not only have you got to have the catalysts there, you've got to have the tubes to mix them so that they're only mix when the beetle wants to fire. So the beetle chooses to release these chemicals, open the valves, let them go into the combustion chamber. They have to be kept separate until that particular time. And then when they do fire, that material has to, and the surrounding material here has to be such that, as it says, the beetle doesn't cook itself. And also, this little opening and everything has to be quite separate to the digestive system and of the beetle, where the waste products pass out of the beetle, so of his digestion pass out. So it's to me, it's such an amazing, a better word would be powerful evidence of design and creation. The other thing is too, the propulsion of the drops uses this, as we mentioned, this little pulse system. And one of the folk that is has become quite an expert in the area of the Bombardier Beetle is Professor Andy McIntosh. Now, he was at the University of Leeds and was at the moment he's Emeritus Professor of Thermodynamics at the University of Leeds. And he has both a PhD and a DSc, a Doctor of Science. He was a mathematician, but essentially he was looking at solving the equations associated with the thermodynamics or combustion theory that occurs in jet engines. So in jet engines, you've got very high flow, very high temperatures, very fast chemical reactions, and modelling the heat flow, energy flow, propulsion and so forth out of these systems requires quite complex mathematics and solving quite complex equations. And that was his area. And he was fascinated by the Bombardier Beetle and began looking into this because were there any clues that could be relevant to applications in jet engine design. And one of the things that he noticed was that this little system that was in the Bombardier Beetle was actually called by scientists pulse combustion. and it's actually used in some engines to give thrust. And as a matter of fact, he points out that it was actually used in the V1 flying bombs that were developed during World War One by the Germans. One of the first rocket bombs, and they used this pulse system. They were called doodlebugs, interestingly enough. They used that particular thing. So, and he points out that at the University of Leeds, they developed a spray system based on the technique used by the Beetle. And this was part of their research that they were doing there. And again, he argues and points out that, the detractors of creationists say, creation is going to limit science. And he points out, well, hang on, this is how we used, by studying creation thing, we're able to actually advance science. And one of the things that came out of it was that there were very clear design features. And he said, as they studied this, they were actually led to a patented spray system which heats water in a special chamber, and they can use that to spray whatever the system was used for, the particular design a requirement that they needed. It's interesting also, he went on to, I noticed in his article that he writes about this, that in 2010, his work, the work that they did at the University of Leeds developing this special spray system that was to be used in industry, won the Times Higher Education Award for the most outstanding contribution to innovation and technology. So that was in 2010. So this particular valve spray system that enabled very powerful sprays and fluid sprays to be developed for use in research. As I said, just repeating that, won the Times Higher Education Award for the most outstanding contribution to innovation and technology in 2010. And so this system has already been used for developing the spray system used in fuel injectors in car and truck engines. So, many of us now have these modern fuel injected, particularly if we have a diesel car, well, even petrol cars now are fuel injected. The fuel injectors in car and truck engines, the design of those injectors, at least some of those injectors, was based on the research done at Leeds University based on the Bombardier Beetle. So I think when we think about this and the fact that the Bombardier Beetle itself is such powerful evidence of irreducible complexity. And what we mean by that is that the evolutionists claim that all these structures, such as in the Bombardier Beetle, occurred with very small, slow changes occurring over a long period of time by random mutations in the genetic code that enabled new structures to form just somehow randomly, and then the ones that were best suited and survived kept on going. Well, I think it becomes fairly obvious when we look at the complexity of the Bombardier combustion system that you've got to have the tubes have got to be, and the tubes have got to be made out of material that is resistant to the chemicals. The tubes have to then have the catalyst or enable the catalyst to be present. You've got to have then the combustion chamber. The combustion chamber has to have special valves that can resist pressure, has to be lined with special material, and the valves themselves too that resist the high temperatures and don't burn or decompose. Then you've got to have all the little pumps and so forth to squirt the material in. You've got to have the codes to make the chemical catalyst and just to make hydrogen peroxide, just to make hydroquinone in the little insect itself requires special biochemical reactions to make these chemicals, let alone to make the catalyst, catalase and so forth that are used in the beetle. So it's and then you've got the muscles that control the little jet system and the little spray device itself. It's a little cannon, you might say, and to be able to move it around, the muscles and the structure of it, plus the nerves that are responsible to control the muscles. All the codes for that are just so complex, and evolutionists have to cling to the thought that this all occurred just by chance. I think it's powerful, powerful evidence right in front of us, clearly in nature, that we have a creator God. It's interesting that just last night, as I was watching the news, and there was an article about the coronavirus, and the commentator at the end of the news on the television station said it seems that this particular year, 2020, is a year that God forgot because of the different disasters, particularly here in Australia. And my thought was immediately, well, hang on, a lot of people have forgotten God. And I think a lot of people have forgotten God. It's not that God has forgotten us. It's thus that I believe we've turned away from God, and God stepped back and said, well, if you don't want me in the picture, that's fine, I'll step back. And I think so many people today don't know about God. They think that science has disproved God. Scientists are trying to develop vaccines for this, for the nasty COVID-19 virus, but people are relying on science. But science can't explain everything, and teams of scientists are trying to, work out and study the immune system and so forth. Whereas our immune system was by a creator. It's so complex and so amazing. We have overwhelming evidence for our creator. And of course the Bible reveals that our creator is a loving God that wants that relationship with us. And I would encourage everyone listening to pick up your Bible and read your Bible. Start with the Gospels of Matthew or John and read about God's love and God's plan for salvation for us. You've been listening to Faith and Science, and remember these can be caught up. These episodes can be caught up by just Googling 3ABN Australia, or one word, .org.au, and click on the listen button. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.